OptRail is a remote monitoring solution for predictive maintenance of railways, switches and crossings to identify train loads and its impact on void and crack growth in rail infrastructure. By installing FPG sensors on the rails, track conditions can be monitored remotely, avoiding dangerous red zone working, reducing maintenance cost, increasing passenger experience, and also building towards a more sophisticated railway for the future.
Over time, because of the vibrations and the weight of the trains, the whole understructure begins to move and shift, which can develop some void areas. Those areas are very dangerous because whenever the train passes over a void, the rail bends, which can cause cracks over time. And in the worst cases, those cracks can even cause derailment. The best way to observe a potential void or crack growing on the track is to send someone during the operational hours to see how the track is behaving when the train is actually moving along it. As you can imagine, sending someone on a live track, it's quite dangerous. And there are accidents, unfortunately, every other month. Switches and crossings are expensive to maintain. There are over 20,000 of them in the UK alone. And they are very difficult to install because most of them have to be assembled off-site and transported to the location. Other time it is mounted on site, but this takes a lot of time and can cause disruption of the regular service. Although switches and crossings represent only about 3% of the network in the UK, they cost more than 15% of Network Rail's maintenance budget. This is the current situation today, because we don't have a system that allows us to monitor the rail status remotely.
Predictive maintenance is similar to human health, finding solutions earlier on for potential failure of machinery. It's much better and cheaper than prescriptive and corrective health measures. One major difference between human body and equipment is that we have a voice. We can feel unwell and tell somebody, and equipment don't have that. So by equipping assets, and especially critical assets such as switches and crossings, we are allowing them a voice. But to monitor that, you wear an Apple Watch. That is an additional electronics that's giving you feedback about how healthy you're keeping. And maintenance is basically about keeping healthy.
So we've got multiple sensors, accelerometer and strain and temperature sensors, which are installed on the crossing and also on the plain line. The principles of operation is fiber bright grating, so they are on a fiber bright grated cable. And we got a fiber optic interrogator, which is inside our cabinet in the yard, about 300 meters away from the sensors. That is constantly emitting light. When this light hits any of the FPG sensors that we have, depending on the environment, the measurement and how it's changed, the reflected light will have a different wavelength than the one that was originally sent. And after a train goes over it, or over time, you will see that reflected wavelength has changed. So there's a shift, there's a wavelength shift. And that shift is what we are measuring. If the ballast underneath the rail is inadequate, i.e. we have voiding, that will manifest itself on the recorded patterns which we obtain by converting the wavelength shifts to SI units when the train passes. So we've considered different options for powering up our cabinet. It can be powered from main supply, or it could be supplied from wind turbines and solar panels. The cabinet itself is weather resistant, it's IP protected, and it's got climate controlled heating and cooling inside of it. The computer that's inside is connected to 4G, which allows 24/7 monitoring of diagnostics, the health, and also the data.
We have managed to identify new knowledge, but more importantly, we learned a lot of practical experiences which can then solve problems.
The ultimate aim of the project is to move from a find and fix or a periodic maintenance to a predict and prevent regime with higher reliability, higher safety, and at a lower cost. So if you want there to be a traffic light alarm system notifying route managers of crossings in need of attention, which will considerably speed up the maintenance response time.
The information gained through the observation of how cracks and voids form over time will help the steel industry and the manufacturers of rails to improve the quality of the materials and of the design. We want to expand the lifespan average of a switch and crossing from 7.5 years closer to 15 years. And this is just the first step, because now Network Rail is imposing new construction standards that will prolong the intended lifespan of a switch and crossing from 15 to 25 years. You always have to innovate. You always have to be at the forefront of science. You always have to experiment with new stuff and putting new materials that have never been used before in the railway industry.
We're hoping that the rail industry in Britain would benefit from the results of our research.
Absolutely, I think it's one of the big growth areas that we're seeing. So there's a huge amount of opportunity in that with Great British Railways working much more closely with the train operators, with the owning companies as well, to really think about what should we monitor, how do we share that data, and how do we make sure we get the best out of that data. So those elements are really vital for us to be efficient, effective, and reliable. One of the issues we do have is that our monitoring fleet is only so big and can't always cover every piece of ironwork, I guess. So it might go through the switch in one direction, but not in the reverse direction, for example, in the diverging route. So having a system that's fitted to rolling stock that's able to give us that additional insight into potential derailment risk will be really powerful for us. It's a huge area of opportunity. The system's going through product acceptance at the moment, but it is the new science. It's a very exciting time for us. It's going down to the next level of understanding the capability of the infrastructure and how we can manage that better to make sure that it is available when we want to run trains, which is ultimately what we're aiming to achieve.